Hi there. We're going to be solving some radical equations with two square roots. The one we're working on right now has two solutions. Both solutions will check. Here we go. First, I isolate one of the radicals. The easiest one to isolate is the first one, which is positive. I'm going to add the negative one over to the other side. Plus the square root of y minus 2 plus the square root of y minus 2. Negative the square root of y minus 2 plus positive the square root of y minus 2 is 0. So I'm left now with one square root, the square root of 4y plus 1 equals 3 plus the square root of y minus 2. Now that I have one square root isolated, I'm going to square both sides. Square. Now I have two terms here, so I have to put parentheses around them and square. When I square a square root, they cancel each other out, leaving me with what's underneath the argument of the function, 4y plus 1 equals. I'm going to write the first set of parentheses in blue. And the second set in black, just so I can do a little color coding. Because I want to clearly show you the distribution method for multiplying. I take 3 from this set of parentheses, the first term, and I multiply by the second set of parentheses. Then I take the second term from the first set of parentheses plus the square root of y minus 2, and I multiply by the second set of parentheses. Then I distribute. 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 Three times 3 is 9. 3 times plus the square root of y minus 2 is 3 times the square root of y minus 2. And then plus the square root of y minus 2 times 3 is also plus 3 times the square root of y minus 2. And plus the square root of y minus 2 times plus the square root of y minus 2 is plus the square root of y minus 2 squared. It's going to happen again, a square root and a square. Cancel each other out. 9 plus 3 times the square root of y minus 2. plus 3 times the square root of y minus 2 is 6. I have 3 square roots. I add another 3 square roots. That means I have 6 square roots. Plus y minus 2, because my square root is squared. Now, if you look at this closely, you'll see that you have 9 minus 2. They're both constants. They're like terms. 9 minus 2 is 7. Plus 6 times the square root of y minus 2 plus y. And now we can use the left side of the equation again. 4y plus 1. Okay. Now we start all over again. I have a radical that needs to be isolated. So I'm going to move the 7 over here and the y over here. Minus 7, minus 7, minus y, minus y. 7 minus 7 is 0. Y minus y is 0. So on the right side of the equation now, I have 6 times the square root of y minus 2. Over here, 4y minus 1y is 3y. And 1 minus 7 is minus 6. Now at this point, probably the best thing you can do is get used to looking for a GCF. It won't always happen, but here it has happened. There's a 3 in this term, and 6 is 2 times 3, so there's a 3 in this term, and 3 will go into that term. So I'll have 3 times y minus 2 equals 6 times the square root of y minus 2. I'll divide both sides by 3. Three goes into 6 2 times. So I'll have y minus 2 equal, I didn't need to do that, y minus 2 equals 2 times the square root of y minus 2. Actually, I did need to do that. Now, okay, what am I going to have to do now? I have to square both sides in order to get this radical off of y minus 2. Now, when I square, let me square here. When I square the right side of the equation, I am not only squaring the square root, I'm squaring the 2. If I had left it as 6, wouldn't be the end of the world. 6 squared is 36. That's not a horrible number, but 2 squared is only 4. And the smaller you can make your numbers, the less likely it is you're going to make a mistake. So let's do this. We're going to have y minus 2 times y minus 2 equals 4. 2 squared is 4. And the square root of y minus 2 squared is y minus 2. Now let me do this. This is going to equal 2 squared times the square root of y minus 2 squared. So that's the magic that happened here. Over here, let me make that first set of parentheses blue, or what's in it blue. I'll take y and multiply it by y minus 2. And then the minus 2. And multiply that by y minus 2. Meanwhile, I'll distribute this 4. 4 times y and 4 times minus 2. And that will give us 4y minus 8. So coming back over here, I distribute the y, and I distribute the minus 2. Y squared minus 2y minus 2y. Now you've got a minus 2 times a minus 2, that's plus 4. Equals, what is it? Come on, kitty, kitty. Come on, kitty, kitty. Well, what is it? Come on. Oh, you're not my kitty. You're not my kitty. You're not my kitty. You're at the wrong house. Have a little visitor. 4y minus 8. There we go. Let's try to get this together. Y squared minus 4y plus 4 equals 4y minus 8. Now I'm going to use the zero principle. I'll subtract 4y from both sides. And I'll add 8 to both sides. (4y minus 4y is 0. Negative 8 plus 8 is 0, which of course is 0. Over here, I'll have y squared minus 8y plus 12. And that equals 0. Now I'm going to try to factor this. There's no guarantee it's factorable. Well, not factorable over the integers, over the rationals. Y, but I always try that first because it's the quickest. 12 equals 1 times 12. This is a plus 12. 2 times 6 and 3 times 4. And then 4 times 3 starts to repeat. And that will be negative 1 times negative 12 because it's positive. A positive number equals a negative number times a negative number, as well as a positive number times a positive number. negative 2 times negative 6, and negative 3 times negative 4. We need to find the factor pair that adds up to negative 8, and here it is. Negative 2 plus negative 6 equals negative 8. What are you going to do? Minus 2 minus 6. And then I double check this real fast. Y times y is y squared. Y times minus 6 is minus 6y. Minus 2 times y is minus 2y. Minus 6y minus 2y is minus 8y. And then minus 2 times minus 6 is plus 12. Or negative 2 times negative 6 is positive 12. It all depends on how you want to look at it. Y minus 2 equals 0. Y minus 6 equals 0. Add 2 to both sides over here on the left. And I'll have y equals 2. And over on the right, add 6 to both sides. Y equals 6. So I have two proposed answers here. Solutions. And we know from already looking at the answers that these are both going to check. But let's finish this out and pretend we don't know. So we'll check out y equals 2, and we'll check out y equals 6, and we'll look at the original equation. Let's do this. Here, we'll put them both here. We'll put that in the middle. Excuse me. And then, there now. Move that up. Over here, I'll put 2 in for every y, and over here, I'll put 6 in for every y. So, the square root of 4 times 2 plus 1 minus the square root of 4 minus 2 equals 3. Uh-oh. It's a 2. Whew. Okay. 2. So this is the square root of 8 plus 1, which is 9, minus the square root of 0, which is 0, equals 3. The square root of 9 is 3, equals 3. That checks. Now let's come over here. The square root of 4 times 6 plus 1 minus the square root of 6 minus 2 equals 3. Well, 4 times 6 is 24, plus 1 is 25. We'll have the square root of 25 minus the square root of 6 minus 2 is 4. Equals 3. The square root of 25 is 5. The square, minus the square root of 4 is 2. And that is 3. equals 3. So that checks. That can happen sometime. We have two solutions here. 2 and 6. That, and notice, first we isolated one of the radicals, then we squared both sides, which meant that we have to actually multiply square roots that have two terms underneath, two terms in the argument. A little bit scary, but we came through it okay. The square root of y minus 2 squared is y minus 2. Then we work all this out, and then doggone it, what do we have? We have another radical that needs to be isolated. So we isolate, we work it out, we come up with a solutions 2 and 6, and then we have to check our answers, because radical equations love to trick us. Yes, they do. All right, now let's move on. There are no solutions to this equation. It's very frustrating to go through all the work to solve this equation that has two radicals in it, so it's work. And then you don't even get the reward of having any solutions. It's very frustrating. Okay, well, what do I do first? Since this is positive, I'm going to isolate that one, and that radical, and I'm going to subtract this radical and this constant over to the other side. So minus the square root of 2x plus 2 minus 1, and do the same thing on the other side of the equal sign, minus the square root of 2x plus 2 minus 1. So the square root of 2x plus 2 minus the square root of 2x plus 2 is 0, and 1 minus 1 is 0. And we're left with the square root of 3x minus 2 on the left side of our equation. Over on the right side of the equation, we're going to have negative the square root of 2x plus 2 minus 1. Okay, and then I'm going to square both sides, but first, I want to make it very hard for me to make a mistake. So, I want to pull out my GCF, okay? Now, first, this minus sign is really a minus 1. Minus 1 times that square root. And then this minus 1 is minus 1 times 1. I mean, isn't it? It's true. But I'm going to pull out a minus 1, a negative 1 GCF. So I want to have a 1 left. Okay, so if I pull out the negative 1 as a GCF, I'm going to have, in fact, let me put a plus sign right here, which is, I mean, that's true. That's plus a negative 1 is the same thing as minus 1. That allows me to more safely pull out a negative 1 and then have the square root of 2x plus 2 plus 1 in parentheses. Now, have I changed this? Let's make sure. Let's make sure I have not made a mistake here. Negative 1 times the square root of 2x plus 2 is negative the square root of 2x plus 2. And negative 1 times positive 1 is negative 1. So I have exactly what I started with. I just put it in a different form. And the reason I did it is that when you have a bunch of negative signs running around and you're going to square both sides, that can become confusing. So I'm going to unconfuse the situation a little bit. I'm going to square the left side, which is only radical, the left side of the equation, and over here on the right side of the equation, I'm going to square the entire right side. And what that means for me is this negative 1 is going to get squared. And parentheses the square root of 2x plus 2 plus 1, parentheses closed, is also going to be squared. This way, that negative sign is not going to be messing me up. We had this, the square root, negative the square root of 2x plus 2 minus 1, and just squaring that could cause some problems. This way, I went to an extra step, but I got rid of a possible problem. It's worth an extra step. So 3x minus 2, now that I've squared the square root of 3x minus 2, that gives me just 3x minus 2 equals negative 1 squared times parentheses the square root of 2x plus 2 plus 1 squared. So the 3x minus 2 equals negative 1 times negative 1 is positive 1 times the square root of 2x plus 2 plus 1 in parentheses times parentheses the square root of 2x plus 2 plus 1. Parentheses closed. Now saying 1 times that, I mean, that's, if this were an English class, you'd call it a tautology, I believe. Just overly wordy, not needing to use that many words. We don't need to say 1 times. When you say 1 times, the 1 disappears. Okay, so now I'm going to make this blue. Not like that. In blue, the square root of 2x plus 2 plus 1 outside the radical, okay? Now, what that's going to let me do is this, the square root of 2x plus 2. And then my plus 1 is going to be written down here. And the second set of parentheses, look at this. There. the square root of 2x plus 2, and then I'm going to put parentheses, square root of 2x plus 2 plus, Now I can't do that either. I can't make it look like that plus 1 is under the radical, because it's not. So you have to be very careful. Plus 1, parentheses closed, and then my plus 1 times the square root of 2x plus 2 plus 1. Okay. So what is that going to give us? Well, we're going to distribute the square root of 2x plus 2 to the square root of 2x plus 2 and to plus 1. And then I'm going to distribute the plus 1 to the square root of 2x plus 2 plus 1. That will give me, I want to go back to black. 2x plus 2. This times this is the square root of 2x plus 2 squared. And then the square root of 2x plus 2 times plus 1 is plus the square root of 2x plus 2. And there's my 1. You don't really have to have it there, but it doesn't hurt. And then plus 1 times the square root of 2x plus 2. And 1 times 1 is 1, plus 1. So now, the square root of 2x plus 2 squared is 2x plus 2. Now, 1 times the square root of 2x plus 2 plus 1 times the square root of 2x plus 2 is 2 times the square root of 2x plus 2. Yes, it is. It really is. And then I've got a plus 1. And notice that this 2 and this 1 are both constants, and we can add them together. That's called combining like terms. So 2x plus 2 plus 1 is 3, plus 2 times the square root of 2x plus 2. I come back over here, 3x minus 2. Okay. Well, I've got a square root that needs to be isolated, so we start this whole cycle all over again. Minus 2x minus 2x minus 3 minus 3. Over on the right, 2x minus 2x is 0, 3 minus 3 is 0, and I'm left with 2 times the square root of 2x plus 2. Over on the right, 3x minus 2x is 1x. And if I subtract 2 and then subtract 3, that means I've subtracted 5. Or you can look at this as negative 2 plus negative 3 is negative 5. Okay. There's no GCF I can get rid of. So we are going to square both sides again. Square x minus 5 and square 2 times the square root of 2x plus 2. That will give me on the left x minus 5 times x minus 5. And on the right, 2 squared, well, let me just write it that way, 2 squared times the square root of 2x plus 2 squared. Okay, now that you know all about the distribution method, or maybe you're already foiling, we'll just say that this is x times x, that's x squared. X times minus 5 is minus 5x. Minus 5 times x is minus 5x. And minus 5 times minus 5 is plus 25. And over here, 2 squared is 4. And the square root and the square cancel each other out. And we're left with 2x plus 2. Yep. So come back over here, we're going to combine these two like terms. X squared minus 10x plus 25 equals 4 times 2x is 8x, and 4 times plus 2 is plus 8. And notice we have a quadratic. So now I'm going to use the zero property, a principle. Zero. Principle. And what that means is I'll subtract 8x from both sides of the equation, and I'll subtract 8 from both sides of the equation, so that I get 0 over here. 8x minus 8x is 0, 8 minus 8 is 0, so I have a 0 on the right-hand side. On the left-hand side, I have x squared minus 18x, and then that's going to be plus 17. 25 minus 8 is positive 17. And then I'm going to factor. We don't often have to factor 17, but this is not going to be too hard because 17 equals 1 times 17, and it also equals negative 1 times negative 17, and negative 1 plus negative 17 equals negative 18. So that was not too hard at all. So we'll have what? Minus 1 and minus 17. X minus 1 equals 0. X minus 17 equals 0. Add 1 to both sides. I get x equals 1. Add 17 to both sides. I get x equals 17. Now all I have to do is check my answers. Okay. So let me erase that. No, oh, all right. And here's the original equation, a giant equation. And I'll check x equals 1. Over here, and x equals 17 over here. All right, so the square root of 3 times 1 minus 2 plus the square root of 2 times 1 plus 2 plus 1 is 0. Is that true? Let's find out. 3 times 1 is 3. This is the square root of 3 minus 2. That's the square root of 1. Plus the square root of 2 plus 2 is the square root of 4. Plus 1 equals 0. Well, you can look at this and not even work it out any further, but 1 plus 2 plus 1, that's going to be not 0, but 4. So we have 4 equals 0, which is false. I bet 17 will work. Of course, I already know it won't, because I looked at the answer, right? 3 times 17 minus 2 plus the square root of 3 times 17 minus 2 plus 2 times the square root of 2 times 17 plus 2 plus 1 equals 0. Well, there's no way this could equal 0, just because square roots are positive. So a positive number plus a positive number plus a 1 is not going to equal 0, but let's work it out anyway. This is the square root of 51 minus 2 plus the square root of 34 plus 2 plus 1 equals 0. So that's the square root of 49 plus the square root of 36 plus 1 equals 0. So 7 plus 6 plus 1, sure it equals 0. This is what? 13 plus 1 is 14. 14 equals 0. No. No. So that happens sometimes, and it's very frustrating. All that work, and you end up with no solutions. Oh dear, oh me. But we'll live through it. Okay, one more. We've already got a radical isolated. How about that? So I can go ahead and square both sides. 3 plus the square root of z minus 6 squared equals the square root of z plus 9 squared. So I will have 3 plus the square root of z minus 6 times 3 plus the square root of z minus 6 equals z plus 9. Okay, so 3 times 3 is 9. 3 times plus the square root of z minus 6 is plus 3 times the square root of z minus 6. And then plus the square root of z minus 6 times 3, that will also give me 3 times the square root of z minus 6. And then plus the square root of z minus 6 times plus the square root of z minus 6 is plus the square root of z minus 6 squared equals z plus 9. So we're going to have 9 plus 6 times the square root of z minus 6. Right, I've got 3 square roots plus another 3 square roots. That gives me 6. And then plus z minus 6 equals z plus 9. And since the 9 and the minus 6 are like terms, they're both constants, I'm going to say 9 minus 6 is 3. Plus 6 times the square root of z minus 6 plus z equals z plus 9. So I come over here, I take away the 3 from both sides, because I have to, I have to isolate that radical now. I'm going to subtract z from both sides. Ooh, look what I get, c minus z is 0. 9 minus 3 is 6. That's what I'll have over on the right. Meanwhile, over on the left, 3 minus 3 is 0, z minus z is 0. I'll have 6 times the square root of z minus 6. Oh my goodness, and look, I'll have z times the square root of z minus 6 equals 0 plus 6 is 6. And now this 6 will go into that 6. So let's divide both sides by 6. There's a 1. Yeah, 6 divided by 6 is 1. So we're going to have the square root of z minus 6 equals 1. And then we're going to square both sides. That will give us z minus 6 equals 1. I'll add 6 to both sides. And I'll get 7. Z equals 7. So all we're going to have to do is check z minus 7 in the original equation, and you see that is correct. Love it, love it, love it. we can ignore that. Can't we? Yeah. Perfect. Okay. Now, we're going to see if z equals 7 is really true. Three plus the square root of 7 minus 6 equals the square root of 7 plus 9. 3 plus the square root of 1 equals the square root of 16. 3 plus 1 equals 4. 3 plus 1 is 4. 4 equals 4. Yippee! That's true.